So I'm going to go over some examples of each category on this unit's delta math. I need you to keep a few things in mind. First things first, you have more problems for each category than I'm going to show, right? So the one problem I do, you might have 3 of that type of problem. The other thing is that my problems aren't going to be the exact same as yours, so you're going to have to make some adjustments based on my numbers. So keep those things in mind, and let's get started. So the first category is finding coterminal angles. A coterminal angle is an angle that ends up in the same position. So when we're graphing angles, those angles need to be somewhere between 0 and 360 to graph them on our coordinate grid. So when I have something that's more than that or less than that, so like if you have something that's negative or something that's bigger than 360, you want to get it between 0 and 360. And the way to do that, but then keep the integrity of the angle, is to subtract or add a full rotation. So for me, I'm going to subtract because I want to bring the 942 down. But if you have a negative number, you might need to add 360 to bring it up. So for me, 942, I'm going to subtract a full rotation of 360 degrees. So if I subtract 360 degrees from 942, I get 582 degrees. That's still not between 0 and 360 though. So I'm going to do another subtraction of a full rotation, and I end up with 222. 222 is between 0 and 360. So basically I'm just subtracting a full rotation until I'm somewhere between 0 and 360. If you have a negative angle, you're going to add 360 until you have an angle between 0 and 360. These are called coterminal angles because they land in the same position. One just has more rotations than the other. The next category is find coterminal angles in radians. So I want my angle to be somewhere between 0 and 2. The way that I'm going to do this is I am going to ignore the pi for now. And I'm really just going to focus on the fraction without it. So I am looking at the fraction -17/3, and I'm just not looking at the pi right now. The fact that it's negative means that it's less than 0, and I want to make it positive. I want to make it somewhere between 0 and 2. So a full rotation of a circle is 360 degrees. In radians, that's 2 pi. So I'm going to add 2 pi, but again, I'm just ignoring the 2 or the pi for now, so that I'm not working with irrational numbers. So I'm going to do in my calculator -17/3 plus 2. And when that's a decimal, I'm going to math enter that decimal. So technically right now I'm at a -11 pi over 3 because I'm just ignoring the pi. It's still negative though. So I'm going to add another full rotation, which is 360, but in radians that's 2. And right now I'm just ignoring the pi so I don't have these weird decimals in the calculator. And that's -5 pi over 3. And it's still negative. So I want to add another full rotation to that. So I'm going to add another 2. And now I'm finally positive at 1/3. And then I'm just going to remember that I took away the pi, so I'm bringing it back. And when I bring the pi back, I no longer have to write the 1 in front. So my answer for this one would be pi over 3 is the same angle as -17 pi over 3. So I'm just adding 2 consistently until I get somewhere between 0 and 2. Now if your fraction is bigger than 2, so for example, let's think of like 3. Let's say your angle was 18 pi over 3. That's like 6 pi, that's bigger. You're going to subtract 2 until you get somewhere between 0 and 2. Right. The next category is find the coterminal, reference, and quadrants. So I'm starting with the angle 1041. And that angle is bigger than 360. So I'm going to subtract 360 from that. And that gets me at 681 degrees. But again, that's still bigger than 360. So I'm going to subtract 360 again. And that puts me at 321 degrees. So this is my coterminal angle. This is an angle from 0 to 360. But it is in the same position because I was only subtracting full rotations, having it at the same starting place. Now, on my coordinate grid, This angle here is 0, and then we go 90, and then we keep adding 90. 270 until we're back where we started at a full rotation. So the fact that I'm looking at 321, well, 321 is somewhere between the 270 and the 360. So it's falling somewhere here. And that puts it in quadrant 4. So you're looking, what angle you have, is it between 0 and 90? Well, that would be quadrant 1. Is your angle between 90 and 180? That would be quadrant 2. 180 and 270, that would be quadrant 3. 270 and 360, that's why I'm in quadrant 4. And then finally, it wants me to find a reference angle. So I'm going to just draw my picture again. Here was my angle, somewhere in quadrant 4. When we're making a reference angle, we make it with the terminal side, the x-axis on that side, and then we drop down. So this is my reference triangle. And in my reference triangle, your reference angle is the one closest to the origin, so right in the middle there. So that's my theta. And I'm looking to find that reference angle. And so let's think about what we know. We know that the angle from the starting point to my terminal side, that is 321 degrees. So my reference angle, which is green, is the part right here that completes the full circle. So together, my 321 plus my reference angle equals a 360 degrees. So my 321 is that big angle, plus my reference angle. Together, those two things complete the circle. So I'm looking to solve that equation. There's also a quadrant 4 equation that we wrote in our toolkit notes, and you can just use that equation. But essentially, you're going to end up with the same thing here. And that's that my reference angle, if I subtract 321, is 39 degrees. Your rule is going to be different based on your quadrant. If your angle falls in quadrant 2, you're not going to use 360. You're going to use 180. So it depends on what quadrant you're in. So these are the 3 answers that this one was asking. All right, find coterminal reference in quadrant again, but now we're doing it in terms of pi. So I'm looking at this negative 23, and again, I'm ignoring pi for now. And what I'm going to do is keep adding that full rotation of 2 until I'm looking at a fraction that's not negative anymore. So when I add 2 to this, I get negative, if I'm just doing negative 23 over 9 plus 2, and I type that in the calculator, I get negative 5 over 9. Which is still negative, so I'm going to add another 2. And when I add another 2, I get 13 over 9, which is positive, and I'm going to add the pi to that. So my coterminal angle is 13 pi over 9. Now, I want to graph that in its standard position. I know that this is 0 and then 90 degrees, but 90 degrees is pi over 2. And instead of thinking it as pi over 2, we're going to think of it as a decimal, 0.5 pi. And this is pi, but thinking of it as a number, it's 1 pi. This is 3 pi over 2, but instead of thinking of it like that, it's 1.5, because 3 over 2 is 1.5 pi, and then this is 2 pi. So what I'm going to do is interpret the fraction 13 over 9. Well, 13 over 9, if I type that into my calculator in decimal form, 13 over 9 is 1.44. So 13 pi over 9 is 1.44 pi. Well, let's think about where 1.44 falls. 1.44 is not between 0 and 0.5. It's not between 0.5 and 1. It is between 1 and 1.5, right? 1.4 is somewhere between 1 and 1.5. So 1.44 is going to be somewhere here in quadrant 3. And I'm doing that by looking at the decimals. So if you have a fraction, you're looking at the fraction part, like 10 over 7. Type 10 over 7 in your calculator, get that as a decimal. Which decimal does it fall between? 0 and 1/2, 1/2 and 1, 1 and 1.5, or 1 and 0.5 and 2. That'll help you with your quadrant. Now that I know that I'm somewhere in quadrant 3, I can draw my reference triangle. My reference triangle is going to happen with the terminal side, the x-axis, not the y, and then I can just drop. This being my reference angle here. So here's what I know. I know that I've got all of this That's my 13 pi over 9. I also know that up here is 180 degrees, right? So the green angle is 180 degrees, which is pi, plus an additional little bit more, right? So it's a half circle plus a little bit more. And that little bit more is the angle I'm looking for. So I know that I have my 180 degree angle, which is pi radians, plus my reference angle, that little bit more. Together, those two things create this 13 pi over 9 angle. And I'm doing this visually. You could also just use the quadrant 3 rule. So my theta is going to happen when I subtract that pi from each side. So it's 13 pi over 9 minus pi. Now you can do this in your calculator by doing 13/9 minus 1, or I can just make this have common denominators by giving the tops and bottoms 9s. And I get 4 pi over 9. So my reference angle is 4 pi over 9. If your angle's in quadrant 4, there's a different rule for that. It's 2 pi minus the angle. If it's in quadrant 1, there's a different rule for that. So it just depends on what quadrant you're in, so just pay attention to that. But for me, I end up with 4 pi over 9. The next one says that we want to find all 6 trig functions level 1. Okay, in what quadrant does theta lie if the following are true? So we have to figure out what we know. Sine theta being greater than 0 means that sine of theta is positive, and cosine theta being less than 0, cotangent theta being less than 0 means that its reciprocal function, which is tan theta, is negative, because cotangent and tangent will do the same thing. So less than 0 means it's negative. All right, so let's think about all students take calculus. All students take calculus. And what does that tell me? Well, the all means that sine is positive, cosine is positive, and tangent is positive. The S tells me that sine is positive, cosine is negative, tangent is negative. Sine's the only one positive here. T tells me sine is negative, cosine is negative, tangent is positive. And C tells me sine is negative, cosine is positive, and tangent is negative. So let's go with our information. Sine is positive in A and S. You can see I've got a plus here and a plus here. Tangent is positive in 1 and 3. You can see we've got positive signs there. But I want tangent to be negative. So tangent's negative in 2 and 4. You can see I've got negatives with that. So what quadrant did I start with twice? My answer to this one is my angle is going to fall somewhere in quadrant 2. All right, next category, find trig ratio given another four quadrants. All right, so I'm given that cosine theta is 72 over 97 and that my angle terminates in quadrant, this didn't copy through. I think it was 4, quadrant, yeah it is. This one should be, and it terminates in quadrant 4. So here's what I know. If it terminates in quadrant 4, I've got something happening here in quadrant 4. And then I can create my reference triangle with the x-axis, the terminal side, and I drop. So here's my reference triangle, and this is my reference angle here. And if I have the cosine, then that means that I have the adjacent and the hypotenuse legs. So the adjacent leg is the next to theta leg, and the hypotenuse is that diagonal. And I can figure out what the third leg of the triangle is using Pythagorean theorem. So I could do 97 squared equals 72 squared plus, let's call it x for now, my other leg. And when I work through that, I end up with 4,225 is my x squared. And when I take the square root of that, it actually ended up being a perfect square. So this side length is 65. So I have to think about what I know about this. In terms of like, if this was a point, what would I know about this point? Well, I went over to the right 72, so that's a positive x, but I went down 65. So that 65 is actually a negative 65. If you don't catch that here, you can use all students take calculus to get the symbol as well. But because it's below the x-axis, that's a negative 65. I'm looking to find the sine of theta. And sine of theta is the opposite leg over the hypotenuse leg. So the opposite is going to put me at negative 65, and the hypotenuse is 97. Now, if you didn't catch the negative 65, and you just have 65 over 97, well, then you can take into an account all students take Calc. And we're in quadrant 4, which tells me that sine is negative, cosine is positive, tangent is negative. So cosine, because I'm looking at sine, has to be negative here, and then I can throw the negative in after the fact. So you can get it from the picture, but you can also get it from the all students take calculus. But what I would be entering in Delta Math is negative 65 over 97. All right, find the trig ratio given another. So I'm given the secant. So I gotta take that information. Well, secant pairs with cosine. And it's the reciprocal, so if I flip this fraction, then I have the cosine. It also says it falls in quadrant 4, so I'm going to draw an angle in quadrant 4. And from here, I'm going to use my terminal side, the x-axis, and I'm going to create the reference angle. And let's think about what I know. Cosine is the adjacent over hypotenuse. And so my adjacent leg is 51 and my hypotenuse is 10. I can find the third leg of the triangle. 10 squared equals root 51 squared, and we'll call that third leg x squared. And you can work through Pythagorean theorem for this, but ultimately you end up with 7 for that third leg. All right, so I've got that. And let's think about what we know about this point. I'm going over to the right, so this 51 is a positive x, but I'm going down for the y, so that's a negative 7. If you miss the negative 7 there, you can catch it later. We want to find the value of cotangent. Well, let's first work with tangent. Tangent theta is opposite over adjacent. It's the TOA in SOHCAHTOA. So the opposite side length is negative 7, and the adjacent side length is root 51. If you missed the negative, that's okay. You can get it at the end. So cotangent is the reciprocal of that. So if I flip that fraction, I get root 51 over negative 7. If you miss the negative, just do your all students take calc at the end. All students take calc. If I am in quadrant 4, then I know that I'm not sure why that deleted, but if I'm in quadrant 4, I know that all students take calc. I know that sine is positive, sine is negative, cosine is positive, and tangent is negative. So you could have added the negative to the end. So sorry that that all deleted. You can rewind the video and pause it if you need to see it. I'm not going to write it out again. But my answer would have been cotangent equals the root 51 over negative 7. And what I would be typing into my calculator is that part. All right, find the trig ratio from a point. So the point is 6, 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I'm somewhere in quadrant 1. I'm going to create my reference triangle with my terminal side and then the x-axis And I'm gonna think about what I know. I went positive 6 over and positive 5 up. These are both positive. Quadrant 1, x and y are both positive. And I could find the hypotenuse by doing 5 squared plus 6 squared equals c squared. And if you work your way through that, you end up with c being the square root of 61. So I'm skipping some steps here. I think you could do Pythagorean theorem. So we want to find the exact values of cosecant. So I know that cosecant pairs with sine, and I know that sine is opposite over hypotenuse. So the opposite leg of this reference angle is 5, and the hypotenuse is root 61. So if I take the reciprocal of that by flipping the fraction, I get root 61 over 5. And just double checking with my all students take calculus, everything's positive here. Sine's positive, cosine's positive, and tangent's positive. So I'm not going to put a negative on this fraction. If it was in a different quadrant, I might. So my answer that I'm typing into Delta Math would be root 61 over 5. All right, and the last one is basic trig equations. I'm going to do this visually, but you can also do this like with a strategy, which I'll teach you in class. But for now, I'm going to stick to the visuals and so you can see the triangles. So here's what I know. I know that cosine theta is negative. So in all students take calc, I'm trying to picture where that could happen. Well, it's positive in 1 and 4, which must mean my answers are going to be somewhere in quadrant 2. So I'll draw a picture for quadrant 2 or quadrant 3. And I'll draw a picture for quadrant 3 as well. All right, so if I'm in quadrant 2, some terminal side in quadrant 2, and if I create the reference triangle in quadrant 2, I've got that. Here's my theta. So I know that cosine is the adjacent over the hypotenuse. So the adjacent leg is this one, and the hypotenuse is 6. And one of those has to be negative, and I'm going on the x-axis here to the left. That puts this as a negative angle, or a negative side length. I could use Pythagorean theorem to find the remaining side length, and I would get root 11. I don't think it affects this problem, but you could do this, like 6 squared equals 5 squared plus x squared, and eventually you get root 11 equals x. So now you have all the legs of the triangle here. So what I am looking to find is theta. So I can find the reference angle, that theta, by doing the cosine inverse of 5, 6. Remember, when we're typing this into the calculator, we're not including the negatives. And the reason that we're not including the negatives is because we're talking about triangles, and triangles don't have negative side lengths. So the reference angle is 33.56. So here's what that tells me. This angle right here is 33.56. But what I want is this angle. So just kind of based on the picture, the blue plus the red together makes this half circle, which is 180 degrees. So if I know that the red is 33.56, I can solve for the blue by subtracting 33.56 from 180. And so I get that my standard angle, 180 minus 33.56 is 146.4 degrees, which makes sense in quadrant 2. It's got to be an angle somewhere between 0 and 180, and I get 146.4. Now, if I do the same process, but now I do it in quadrant 3, I've got some angle in quadrant 3, so I'm going to take the x-axis and drop this down, and this is theta. All right, so what do I know? I know that I have the adjacent leg and the hypotenuse, and again, we're going to the left, which means this is negative. You don't really need this side, but you can find it. So from here, I'm going to find my reference angle by doing, anytime I'm solving for an angle, I do the inverse. So the inverse cosine is going to give me that theta. So I'm going to do the inverse of 5/6. And again, I'm not including the negative because we're talking side lengths. I got 33.56 again. which you should, we're doing the same thing. So that's this red angle. But what I want is all of this. So I want this half circle, which is 180 degrees, plus my red angle, which is 33.56. Together, the half circle and the red make that big angle. So I'm just gonna add my angle to 180, and I get 213.5 degrees, which makes sense for quadrant 3, because quadrant 3 needs to be somewhere between 180 and 270. And then finally, if you wanted to check your answers, you would go to your calculator, you would just make sure you're in degree mode, which I'm not. And then you would take the cosine of each of your angles. So the cosine of my first angle, 146.4, and the cosine of my second angle, 213.5, are both about negative 0.83, and I wanted my cosine to equal negative 5/6, which is about negative 0.83. You can see they're a little off, and that's because I rounded them, but they're pretty close, right? So the two answers that I would put in Delta Math is this, and the way that I would put it is, I think you type the first one, and then you put a comma, and then you type the second one. And that's how it would be entered into Delta Math. So hopefully this helps. Just keep in mind, you're doing different numbers than I am, which might mean you're in different quadrants, which would mean you're using different rules, but the same idea. And then also you're doing more than one of these problems each, so you might be going through them. Hopefully this helps.